All right, today we're going to dive into something that's basically the invisible engine making your entire digital life possible. It's called the transport layer, and it's the behind-the-scenes hero that makes sure everything you do online just works. So let me start with a question. Have you ever stopped to think about how a huge file downloads without a single error? Or how your video call stays perfectly in sync? It's kind of a miracle when you realize the internet at its core is a chaotic, unreliable mess. You see, the internet's basic delivery system is like a postal service that's super fast, but also really sloppy. It knows the destination address, but it makes zero guarantees that your data packets will all show up, that they'll be in the right order, or that it won't just dump a mountain of mail on your doorstep all at once. So how do we fix this chaos? Well, the very first step is to make sure the data doesn't just get to the right computer, but to the exact application that's waiting for it. This is where something called process-to-process communication comes in. And here's what that really means. It's not enough to just deliver a package to the right building address. The transport layer acts like the mailroom manager inside that building, carefully sorting every single piece and hand-delivering it to the right person, or in this case, the right app. And how does it do all that sorting? With this really clever little tool called a port number. You can think of a port number as a specific office number or a mail slot for every single application running on your computer. Your web browser gets one, your email gets another, your game gets a third. Servers use these permanent, well-known numbers, while your machine just grabs temporary ones as it needs them. And this right here is the magic of multitasking online. Your computer's IP address, that's the building. But the port numbers are all the individual office mail slots inside. It's exactly how your one machine can handle a video call, a big download, and 10 browser tabs all at the same time, without any of that data getting crossed. Okay, so now that the mail is getting to the right desk, the transport layer gives us a choice. It offers two very different delivery services, each for a different kind of job. You can think of it like choosing between sending certified mail or just a quick postcard. On one side, we've got TCP, the Transmission Control Protocol. This is our certified mail. It's meticulous, it's reliable, and it double and triple checks that every single piece arrived perfectly and in the right order. But on the other side, we've got UDP, the User Datagram Protocol. This is our postcard. It is incredibly fast and simple. It just scribbles a message and tosses it in the mail. No confirmation, no tracking, just speed. So the whole game is about picking the right tool for the job. You know, for a web page or a file transfer, every single bit has to be perfect. One little missing piece of data could corrupt the whole file. That's why I use TCP. But for live video streaming or online gaming, speed is king. If you lose one tiny packet, you might see a microglitch for a split second, which is way better than the whole stream freezing. That's where you want the speed of UDP. So, how in the world does TCP pull off that certified mail level of reliability on such a messy network? Well, it has a really smart playbook. Before it sends even one byte of your actual data, TCP is very polite. It starts with what we call a three-way handshake. It's like a quick phone call. Your computer sends a SYN packet, which is like saying, "Hey, you there?" The server replies SYN-ACK, which means, "Yep, I'm here, and I hear you." Then your computer says ACK, which is like, "Great, let's talk." Now the connection is solid. As soon as the conversation starts, TCP tracks everything using sequence and acknowledgement numbers. The easiest way to think about it is that TCP is numbering every single page in a really long letter. The sequence number says, "This is page 5," and the acknowledgement number says, "Awesome, I've received everything up to page 4."
So every single time a chunk of data arrives safely, the receiver just fires back a quick confirmation. That's the ACK. It's the digital equivalent of just saying, "Got it, send the next piece."
So what happens if one of those "got it" messages never comes back? Well, TCP doesn't panic. It starts a little timer for every packet it sends. If the timer runs out, it just shrugs, assumes the packet got lost, and calmly sends it again. This simple little trick is what guarantees nothing ever gets lost for good. TCP is also smart enough to not send data too fast. It's got this great feature called flow control, which stops the sender from totally overwhelming the receiver. It's basically like the sender constantly checking in and asking, "Hey, are you keeping up or should I slow down a little?" And the way it does this is with something called the receive window. With every single "got it" message it sends back, the receiver also includes a little note that says, "By the way, I have this much space left in my inbox." The sender sees that and promises not to send more data than the receiver can actually handle, which prevents any digital traffic jams.
So let's zoom out. After seeing all these clever tricks and mechanisms, what's the big takeaway here? What does this all really mean for us?
Well, the transport layer really is the unsung hero. It's the invisible engine that creates order out of pure chaos. It lets your computer have dozens of conversations at once. And, maybe most importantly, it's constantly managing that crucial balancing act between perfect reliability and raw speed that literally powers our entire online world.
And this quote just nails TCP's core promise. It's saying, look, we know the journey across the internet is a total mess. Data will get jumbled. But we guarantee that by the time it gets to your app, the final message will be absolutely perfect.
And that leaves us with a final thought to chew on. In a world that wants everything, 8K streaming, instant VR, you name it, faster and faster, how are we going to keep managing this fundamental trade-off between speed and reliability? What does the future of the transport layer even look like? Thanks for watching.